All right, let's look at theorem 1. It's called ABCD property. All right, it's kind of nice, huh? It says this, reflections preserve angle measures, betweenness, collinearity, and distances. All right, so since we have a lemma saying that once you have distance preserving, this is going to actually implies all the other three, right? So therefore, so this is by lemma. So which means that all we have to do is just show that the reflections are isometries or distance preserving. All right, so there are two kinds. One's line reflection and the other one is a point reflection. Since the proof for the line reflection is given in the book, I'm going to just do point reflection, so S sub C. So what we want to do is we want to show that S sub C, point reflection, is distance preserving. All right, so here's the sketch of the proof because it's a little bit tedious. All right, so we're going to start with any distinct points A, B from the plane, right? We know that if they are the same points, and if you map it, and it's going to end up with the same point. So we're just going to assume that there are two different points, A and B. All right. So there are a few cases we can consider. So let's just say that one of the points is actually the same point at C. All right, that could happen, right? So the picture-wise, so you have, let's say A is different from C. So here's a C, but C happens to be the same as B, right? Then A is different, right? So we want to show that the A prime B prime is equal to AB, right? So if you construct A prime, so you're going to go here, go through C, and go to the other side, same distance, and then we have A prime. Right? Since B is the same point as C, after the point reflection, it's not going to really move. So B is actually same as B prime. All right, so the argument goes kind of like this. So if you start with A prime, B prime, all right? But B prime is same as C, so it's going to be the same as A prime C, all right? But by definition of a point reflection, A prime C is the same length as AC, right? But C is the same point as B, so this is actually AB, right? Then we're done, right? We're done with this case. Okay, let's look at case 2. Right, so let's say A and B are different from C, and that they are non-collinear. Right, so C is over here, and maybe A is over here, and maybe B is over here. Right, so let's construct the A prime. So with a point reflection. So you're going to see that A prime is going to be over here. So this is A prime. And if you construct a B prime, so you're going to go here. And so it's going to be the same amount there, same distance there. Then we have a B prime. All right. Then we can visualize a triangle here. So we have A, B, C. So I'm going to just draw a triangle here. And you have A prime, B prime, C. All right. And you can see that here, these are vertical angle here, right? By, we can use side, angle, side. So by side, angle, side, we know that these two triangles congruent to each other. So ABC and A prime B prime C. So therefore, we know that A prime B prime, right? So this guy is going to be, maybe I'll use a different because that's not given. So maybe this guy is going to be corresponding to that guy. So we know that A prime B prime is equal to AB. So this is by corresponding parts of congruent figures, right? So therefore, we have a distance preserving there, right? How about the last case, right? So A and B are different from C, but what if they are collinear, right? So we have here, maybe I'll put here, A here, maybe B here, and then probably C here. They're collinear, right? Then you look at the, so we're going to construct A prime. So you have go here, right? So A prime is probably around here, A prime. All right, and a B prime, so it's a little bit hard to see, but you go here, so you go this way the same amount, so you have a B prime. All right, so let's find it. So you have we have A prime, B prime. Let's start with that. So you have A prime, B prime. Right, so A prime, B prime. So we're looking at, so it's kind of hard to see, but we're talking about this length, right? Right, so this is going to be the same thing as, right, in this particular betweenness condition. Other ones are very similar. Right, then you can see that this is same thing as B prime C plus A prime C, right? But by definition, B prime C is same thing as BC, and A prime C is same thing as AC, right? So you have BC plus AC is same thing as AB, right? So then we're done. So we check the all three. And of course, you have a different betweenness condition, but you can do that in a very similar argument, right? So the theorem 1 state called the ABCD property, it says that the reflections preserve angle measures, betweenness, collinearity, and the distances, right? That's it. I hope that this was clear.